The problem is that all modern theories, from Einstein's general theory of relativity to laws of thermodynamics, are based on interactions of the visible matter or on its logically predictable behavior, though here, as well there, are many strange things. Let's take, for example, black holes in the universe. These mysterious objects, unexplored by contemporary science, which absorb matter. Yet, before we look into these things and also shed light on the issue of the objects of the formation of which is directly linked to black holes, I would like to ask you first, what do you know about black holes? Anastasia. Well, not as much as I would like to. Black holes are invisible to the outside observer because they prevent both light and any other radiation known to science, as well as objects from escaping. At present, attempts are being made to identify black holes using only indirect signs by means of studying their interaction with the surrounding matter. The black hole is believed to bend the geometry of space and time around itself. At the current stage of development of astrophysics, it is assumed that the black hole is some localized area of outer space, formed by unrestricted gravitational compression of massive celestial bodies. As I understand, this is something like a gravitational grave in which everything disappears once it gets inside. The boundary of such an area is called the event horizon and its radius the gravitational radius. It is considered that the latter depends directly on the amount of matter pulled into the hole. As the mass of the black hole increases, its size also increases linearly, that is, its radius increases. The size of this object may vary. The modern theory of stellar evolution regards the formation of black holes to be the result of the collapse of massive and supermassive stars. As I understood it, when nuclear fuel runs low and thermonuclear reactions terminate inside a star, high temperature and pressure, which prevented the contraction of the star, now decrease under the influence of its own gravity. If the mass of a star is lower than 3 masses of the Sun, the star won't turn into a black hole. It will just become a neutron star or a white dwarf star. And if the mass of the star is more than 3 masses of the Sun, scientists believe that a catastrophic collapse is unavoidable. Its entire matter will rapidly cross the event horizon and the star will become a black hole. Based again on the modern theory of stellar evolution, it is considered that out of 100 billion stars, there must be at least 100 million black holes. Just in our galaxy, thousands of black holes are supposedly roaming and completely absorbing all the gas and dust clouds and stars which inadvertently happen to be in the way of black holes. There are assumptions that supermassive black holes, with a mass of billions of suns, may be located in the center of our galaxy. Rigdon. Well, that's not bad. You get the general idea of how the global science currently marks time, getting caught up in a vicious circle of pointless discussions. Anastasia. I might not be thoroughly aware of the details of their discussions, but as they say, I have a general idea. Also, something else drew my attention. It is assumed that within the black hole, time and space are significantly distorted due to enormous gravitation. The common Euclidean geometry might not be true there, since parallel lines may well intersect and so on. Some even express opinions that everything within the black hole should in principle fall into its center, where later on stellar matter may compress to such a degree that eventually it turns into a point with an infinite density. That is, a singularity may arise. Rigdon. This is just theorists trying to fit their mind-derived conclusions to the far-fetched Big Bang theory, as they believe the Bang appeared from an infinitely dense point in which the entire matter of the universe had supposedly been concentrated and condensed, and when something inside this point had provoked the Big Bang, matter started to fly apart in all directions, and the process of the expansion of the universe commenced. Since numerous questions arise, to which scientists are unable to find answers from the perspective of the material worldview, such confusing modern theories appear. The authors are simply leading each other up a blind alley. They try to explain phenomena using the database that is already known to them. As a result, while developing a theory of the origin of the universe or for example black holes, they find themselves in a situation similar to that of a fable about an elephant. That is, instead of addressing the question of where the elephant appeared from, why it moves, and wants to eat, they studied the trajectory of movement of elephants in the African savanna, the probability of what kind of plants elephants may eat on their way, and the availability of plants in the locality, and what qualities these plants have. So it is with scientists, what they see is what they discuss, whereas what they do not see and what does not fit into their world outlook, in principle, does not exist for them. Anastasia. But perhaps the funniest thing about this modern theory is, in my opinion, the so-called initial black holes. According to scientists' assumptions, such black holes supposedly appeared right after the Big Bang, approximately about 14 billion years ago, when the expansion of the universe started. There is an opinion that the black hole is always ready to absorb any radiation or substance, thus increasing its mass. Hypothetically, according to the notion of scientists, sizes of black holes may vary from a super small black hole having the mass of just 1,015 grams, which supposedly may have remained intact somewhere in the open universe until present, to a supergiant and supermassive one, which is hypothetically located in the center of the galaxy. Even if we assume that after the Big Bang, matter continued to fly apart at the maximum speed possible for 1,000,000 years, and only afterwards a single super small black hole formed with a mass of just 1,015 grams, but having an insatiable, keen gastronomic appetite, it would mean that there would now exist one gigantic black hole instead of the universe. Rigdon. I'm glad you understand this. With a theoretical scenario such as this, the universe would have ceased to exist at least 5 billion years ago. Anastasia. That's a perfectly fair comment. So in general, black holes are a very interesting and captivating topic, especially when you read the research papers of people who seek to know and unravel the mysteries of the universe and who write for people. On the other hand, truth to be told, there are plenty of papers in which authors evidently discuss black holes out of boredom. Obviously, they worked on their papers just like in a Russian saying, where I sneezed, I put a comma, where I hiccuped, I put a colon, and where I snuffed, I put a full stop. So being an outside observer of various twists and turns in science, my impression of black holes is like in a popular joke. What science knows on this subject is that it does not know anything. Rigdon. Yes, something like that. Many scientists make a mistake when they concentrate their efforts and sometimes even waste their lives on developing a dead-end theory. People simply lack the basics, knowledge and a guideline in the right direction of research. Having these, it is quite possible to achieve a revolutionary breakthrough not only in science but in the development of the society as well. I am confident that the information I've already shared and will share further will largely contribute to this, should people choose it. Anastasia. But what is the black hole in reality? Rigdon. In reality, what people call the black hole on the scale of the universe is a transient phenomenon, which itself does not have any mass. Emergence and disappearance of any number of black holes within the universe do not violate the law of constancy of the total mass of the universe. Even the most gigantic black hole, as a matter of fact, exists for a relatively short period of time, and its mass equals 0. However, it plays a tremendous role in the astrophysical transformations of the universe. Associatively, I would compare a black hole with a thought. After all, a thought cannot be seen, it cannot be weighed or touched, but it does exist since it has appeared in our consciousness. The thought has a volume, at least in terms of information. It is transient in its existence, because it is quickly followed by other thoughts. The thought has no mass, but it can have enormous consequences in the material world. In reality, it is nothing. Anastasia. Nothing. For the present day human understanding, nothing is a vacuum at best. Rigdon. Speaking of which, this vacuum is far from empty. Here is a simple example. In the interstellar space, the so-called high vacuum prevails. Its average density is less than 1 molecule per cubic centimeter. If, for comparison, we take the most rarefied vacuum created by people, it contains around 100,000 molecules per cubic centimeter. Scientists already understand that even the absolute vacuum in which particles are supposed to be completely absent is not an absolute void, free from any properties. Even now, modern physics has already approached the theory of the physical vacuum, perfect vacuum, translator's note, as scientists have named the lowest energy state of quantum fields. The physical vacuum in the said theory is characterized by the absence of any real particles, yet, at the same time, it contains all sorts of virtual particles. However, there is another theory, though persistently not recognized by the official science, wherein particles and antiparticles, of 6 classes, are regarded as originating from the initial vacuum by means of its exfoliation along the spin with the emergence of right and left torsion fields, a kind of catalysts triggering the birth of raw matter. Time will surely judge who is closer to the truth. The problem is that in reality, many scientists, wanting to comprehend the truth, face its false reflection in their own consciousness. They are in a rush to announce the theories which are the most convenient for them, and defend the rightness of these theories for a long time, wasting years of their lives and straining their own and other people's nerves, and not even thinking about the deeper causes of why such an inversion takes place in their consciousness. In reality, people are not yet aware of many things about the invisible world, about how powerful the animal mind is in this world, and how important it is for every person to take care of their own spiritual purity, for it is the latter that reveals the truth of the beyond in its primordial nature. Anastasia. Yes, I was recalling this theoretical scheme of particles and antiparticles generation. It is amazing that everything there is also by the scheme of the diagonal cross. Once you made a very clear and associative comparison of the universe to an ocean in which everything is filled to the limit. And what is a black hole in the universe if we look at it using this figurative comparison to an ocean? Rigdon. The black hole in the universe looks, relatively speaking, like an air bubble in the ocean waters. Yet, it only looks like a bubble, but does not correspond to it, because a bubble in the ocean waters is filled with air, whereas the black hole in the vastness of the universe is not filled with anything at all, at least in the human understanding of this phenomenon. Anastasia. In other words, the black hole is like something, a foreign inclusion that is not typical of the material world. Rigdon. Yes, you could say that. Anastasia. You mentioned that the role of the black hole in astrophysical transformations of the universe is enormous. Please tell us more about this and about the main functions of the black hole, at least by using associative examples. Rigdon. Well, the functions of the black hole can be very conditionally compared to the immune response, and to be more precise, to immune cells in the human body, which protect the organism from various causative agents of diseases, identifying and destroying such pathogenic or degenerated cells of the organism, tumor cells, and so on. If an extraneous agent, such as a virus or a pathogenic microbes, enters the organism, our immune cells find and destroy it. If a cell or a group of cells become defective or stop functioning properly, and, for example, begin to divide uncontrollably, the immune cells put things in order here as well by destroying such unruly cells. However, such a comparison would not be entirely accurate regarding black holes in the universe either, since immune cells continuously prowl the expanse of our organism in search of trespassers of the permitted limits. Black holes, on the other hand, immediately appear in the universe, out of nowhere, and only where it is necessary, and then later disappear back into nowhere, and that they disappear instantly, often, but not always, leaving after themselves, in the material world, whole clusters of star fragments and huge clouds of dust and gases, which are fairly easy to detect with modern equipment. This residual matter, after the destruction of the main pathogenic matter, is similar, let us say, to the rubbish that has fallen from a conveyor in a stone crushing and processing works. It is difficult to explain how something appears out of nowhere, destroys whole star clusters at times, and then disappears into nowhere. At that, the black hole does significantly distort space and time around itself and does have tremendous gravity pull, affecting the surrounding matter. The black hole is the only thing that can be called the real void or nothing, since there is nothing material there in human understanding. Anastasia. Yeah, well, this will be difficult for scientific materialistics to comprehend. After all, taking into account the above-mentioned information, the following question arises. Who controls this process out of nowhere? Who detects such defects in the universe and initiates the emergence and the disappearance of black holes exactly in those areas? Rigdon. In order to understand these processes, not to mention translating them into formulas, one should have a fundamentally different worldview. Anastasia, you mentioned that the mass of the black hole equals 0. And how is the matter which it absorbs processed? You said that the formation of the heaviest micro-objects in the universe directly relates to black holes. Does this mean there should be some mass after all? Rigdon, I believe that once you grasp the principle of operation of the black hole, such questions will disappear by themselves. So how does the black hole draw matter in, and where does it disappear afterwards? The black hole is, let's say, some anomalous area. Being a non-material structure, it appears in those parts of the universe in which certain perturbation of the fields exists. Its objective is to destroy the matter that causes these perturbations. The very fact of the presence of the black hole in a given part of the universe causes space-time deformation. In other words, the black hole itself triggers the distortion of the smooth flow of time at a given region of space. This leads to certain interactions resulting in tremendous gravitation, which starts to draw in the material structure. Is this clear? Anastasia. Yes. Rigdon. Let us go on then. When matter is attracted, fragments the size of the moon, for example, begin to become deformed, already as they approach such an anomalous area due to an immense force of gravity, and once matter begins to enter the accretion zone, the most powerful gravitational field is created, and matter is torn to pieces. It becomes like a kind of mincing machine. Anastasia. Please specify whether the term accretion zone is used here in the same meaning as understood by contemporary scientists. You mean the accretion disk as a powerful source of radiation which revolves around the black hole and forms during the fall, accretion, of matter of a neighbouring star or of interstellar gas on this object under the influence of its gravitational field. Is this correct? In other words, does matter upon collision with a black hole begin to orbit it, forming this rapidly rotating disk? Rigdon. Yes, a very important development happens during such matter grinding. The force is such here that it simply pushes information building blocks away from one another so that they can no longer remain in their strictly specified positions, and that is why they break away from their information order. As soon as the information order, thanks to which matter was created as such, disappears, information gets discharged from the material structure, and matter disappears. There is a paradox here because the black hole itself does not influence information building blocks, yet it directly affects matter. The latter is drawn with a great force, and information building blocks are pushed away from each other, and as a consequence, matter disappears. Anastasia. It means that information is not destroyed. Matter is created based on information, and once information is discharged, matter ceases to exist. Rigdon. Correct. If we describe this entire process using the associative example of our conditional experiment, we will have the following. Imagine that you have built a castle of invisible foam plastic building blocks, thus making it visible. Next, you carefully lift it up and simply throw it into the aquarium filled with water. What will happen? Naturally, having collided with the water, the castle will break into small components. In our case, it will shift to another state. Matter will disappear, and only information will remain in the form of those primary invisible foam plastic building blocks, which will be left floating on the water surface. The question is, where will the castle itself, matter, disappear to? It is clear why my question brings a smile to your face. You'll say, to the same place where the donut hole disappears once you eat the donut, and you will be perfectly right. Now imagine that the aquarium is a bit bigger, and there are at least 10 people like you standing above it with castles in their hands, and all of you almost simultaneously throw your castles into the aquarium. When your castles come into contact with water, the foam plastic building blocks, individual information building blocks or blocks connected in clusters, do not remain floating on the water surface, but immediately bounce off of it, as if off something super dense, like a tennis ball off the asphalt. Have you imagined this? Well, this is exactly, albeit in a slightly distorted way, how a black hole operates. Anastasia, and what happens to information building blocks, these clusters? They represent the smallest matter, but it is still visible nevertheless. They aren't still separated into invisible information building blocks, are they? Rigdon, smiling. Well done. I see you follow this situation. The form of the black hole is spherical. When information gets discharged from matter, when information building blocks become detached from the processed matter, a certain part of them becomes detached as whole groups, clusters. It is these clusters that become the short-lived objects having the mass of 0.8 gram, which come directly from the poles of the sphere as background radiation, and the notion of poles in this sphere is relative because what matters here is the observer's position and the accumulation of the processed matter in relation to this sphere. Anastasia, looks like the process which takes place with matter near the black hole may well be compared to another formatting of a computer disk when all the information on the disk is deleted. Why are these objects short-lived, and why do they exist for just fractions of a second? Rigdon, because they do not have any life program. They simply break up into separate information building blocks. The paradox is that information building blocks simultaneously exist in two states, as energy and as matter, in form of a cluster of these information building blocks when they form the material particle. In other words, they sort of don't exist, and simultaneously they do exist. Individual information building blocks don't have any mass, but it is information that creates matter with its mass, as well as space, gravity, and time, and information is controlled by the one who created everything. He created information as a force capable of generating the energies which form matter in human understanding. Incidentally, these information building blocks, upon the formation of particles of little information, the neutrino and such, to a large extent distort Einstein's well-composed theory of relativity. The thing is that some of these particles, due to the simplicity of their structure, interact with other particles in the universe to only a small degree, at least in our dimension, which allows them to move over the vast expanse of the universe at a speed that considerably exceeds the speed of light. Anastasia, speed that exceeds the speed of light? In that case, the very fact of the existence of such particles will make people reconsider not only Einstein's theory, but many other aspects of contemporary physics as well. Rigdon, undoubtedly, something will have to be reconsidered. But on the other hand, this will significantly deepen people's understanding of the processes of the interaction of matter in the universe. And perhaps it will bring mankind closer to the knowledge of such physical manifestation of time as space. So, both the fastest and the heaviest micro-objects of this world are made of information building blocks, just like everything else. Anastasia, and if hypothetically we imagine, say, a neutron star, which would consist of such heaviest, short-lived objects, that means that it would decrease in its size by hundreds of times, and its mass would increase, so the gravitational contraction of the star would increase as well. Roughly speaking, in this case, could such a star undergo a total gravitational collapse and transition to the state of the black hole? Rigdon. Hypothetically, we can imagine whatever we like, of course. However, what you've described is impossible in reality, since it is incompatible with the nature of the material structure. Any material structure would simply collapse under such a force. That is, it would cease to exist as matter because during such a process, certain conditions would arise which would inevitably push information building blocks apart. Also, gravitational forces had their limits, so such a thing is simply impossible. Let's take, for instance, the processes which take place near the black hole. The short-lived objects I've told you about break up into individual information building blocks quite quickly, as soon as the energy which connects them begins to decrease. It is difficult to comprehend these processes with a mind biased in favor of a purely material perception of the world. After all, sooner or later, any person in their spiritual development will face the boundaries of such a limited understanding, which conceals a completely different world and totally different laws. No matter how huge a star is and how many solar masses it contains, it will never be able to transform into a black hole in the modern sense, because matter will never be able to undergo total gravitational collapse. Matter consists of information building blocks, and information building blocks are indestructible. They can neither be destroyed nor changed, and they are quantitatively consistently constant in the universe.